So now we will move forward into multiplying other types of polynomials. We have looked thus far at multiplying monomials to other polynomials. We have looked at multiplying two binomials together. Let's take a look now at multiplying other various polynomials. It says here when multiplying polynomials, each term of one polynomial must be multiplied by each term of the other polynomial. Pretty much as we've stated thus far, we're just using the distributive property where each term in the first polynomial must multiply each term in the second polynomial. So let's start here with 56. It says use the horizontal format. Notice it's horizontal because it is written left to right. It is horizontal. It is a flat horizon surface, horizontal. Slope of 0, when you get into college algebra, y equals any number. Okay, number 56, notice again, a binomial 3x minus 2 multiply a binomial 2x minus 3. 2 terms times 2 terms gives us 4 terms. And then we will look to simplify 4 terms if possible. (3x minus 2 times 2x minus 3). Go to the full view. FOIL method. 3x multiplied 2x is 6x squared. Outside product, 3x times negative 3. Again, positive times negative is negative. 3 times 3 is 9. This factor of x here, multiplying, gives this a minus 9x. Product of the inside here, minus 2 times positive 2x, gives us a negative value. 2 times 2, or 2 squared, 2 times 2 is 4. This factor of x here makes this a negative 4x. Last product, negative 2 times negative 3, and we're multiplying, not adding or subtracting any of this. Multiplying negatives makes this positive. 2 times 3 is 6. So we get our 4 terms here. Noting that the 2 middle terms are like terms. How many x's? Well, I have negative 9, which is small, but now I have negative 4 as well. Combining those, I have negative 13. For my simplified trinomial, right, this is a trinomial, 1, 2, 3 terms. My first term, positive 6x squared. This gives me the degree of the polynomial 2, and my leading coefficient, 6. My constant is positive 6. Let's go back to the PowerPoint. We're looking here at the binomial x squared plus 3. And we're multiplying this to a trinomial, x squared minus 6x plus 2. So what changes for us here? We have a binomial times a trinomial, 2 terms, multiply 3 terms. Well, what's 2 times 3? It's 6. So multiplying 2 terms to 3 terms should give us 6 terms. Why? Here's a product, 1, 2 products, 3 products, 4 products, 5, 6 products. So we're multiplying 6 different times. Let's go ahead and try it out. Distributing the x squared to each of the 3 terms. X squared times x squared. X to the 4th power. X squared times negative 6x is a negative 6 times x squared, which is x cubed. X squared times a positive 2, or a positive 2 times x squared, is positive 2x squared. Next step here is to distribute the 3 to this entire trinomial with multiplication. Now I want to show us that it's kind of neat. I can continue writing all of my polynomials over here, but now I'm going to think ahead and say, I'm going to go ahead and start thinking about stacking like terms so that it might make it easier to combine. I will already know where the like terms will combine, and this is what I mean. Positive 3 times x squared is positive 3x squared. So I'm going to write it right here. Just a sort of reminder that these 2 terms, because they are like terms, I'm going to need to combine them in some capacity because they're both x squareds. A positive 3 times a negative 6x. Positive 3 times negative 6 is negative 18 times x. Positive 3 times a positive 2 is a positive 6. Well, notice here that with this binomial multiply this trinomial, I do get 1, 2, 3, 4, 5, 6 terms as we predicted. But of those 6 terms, only 2 of them can combine together. Well, that's fine. We're going to go from 6 terms to 5 terms. Positive 2x squared combined with a positive 3x squared. How many total x squareds do we have? Positive 5x squared. We get that because when you combine positive 2 with positive 3, you get positive 5. Each term here has a different degree or exponent. 4, 3, 2, 1, 0. So here, and it's in standard form, right? Because our degrees are descending as they're supposed to. Where our degree of the polynomial is 4, the leading coefficient is understood to be a 1x to the 4th, and our constant is a positive 6. Looking at 65. 65 says we have the trinomial 3x squared minus 4x minus 2. We will multiply that to the binomial 3x squared plus 1. This is very similar to the previous example. The only difference is we've sort of switched around the idea. Previously, we had a binomial times a trinomial. This is a trinomial times a binomial. But it's the same thing, right? Because 3 terms times 2 terms will still give us 6 terms. Likewise, right? Multiplication is commutative. This is a number multiply a number. We could just call this is just representing some number. 3x squared minus 4x minus 2. If I gave x a value, this would just end up being a real number, say 7. So this is some number, call it A. This is some number, call it B. Well, again, the cool thing is that multiplication is commutative. If you want to, you can switch around these factors. Place the binomial factor out front, then you can just look to distribute those two terms in the binomial. Likewise, though, you also have the right distributive property. You can start here and say, I'm going to distribute this 3x squared here, this 3x squared here, this 3x squared here. The right distributive property works. Me personally, it doesn't bother me which polynomial is on which side. Some books teach you to take the smaller polynomial factor and move it to the front and view it that way. You also have this. You can just distribute on this side. At the end of the day, all of the terms have to multiply together from one polynomial to the next. So leaving it here, this term has to multiply both of these terms. This term has to multiply both of these terms. This term has to multiply both of these terms. Let's just go with that. 3x squared multiply 3x squared. 3 times 3 is 9. X squared times x squared is x to the 4th. Also think of it as any number times itself, right? Well, any number times itself, we can write that as that number squared, right? 3x squared times 3x squared is that number squared. Well, again, right here, if you have some number 3x squared squared, you're going to square the 3 to get 9. You're going to square the x squared to get 4. Just a fun little fact to show us that we can rewrite that product. 9x to the 4th can be rewritten as the quantity 3x squared raised to the 2nd power. But I digress. Let's move on. This 3x squared times a positive 1. Positive 1 times 3x squared is just positive 3x squared. Any number times 1, you're just going to get back that number. All right, now we move on to the minus 4x. Minus 4x multiply a positive 3x squared. Minus 4 times positive 3 is minus 12. X times x squared. We now have 3 factors of x, or x cubed. Minus 4x times positive 1. Again, you multiply it to a positive 1, you'll get back the minus 4x. Lastly here, minus 2 multiply 3x squared. Minus 2 multiply 3 is minus 6 multiply the x squared. Lastly, minus 2 multiply positive 1 is a minus 2. So again, 3 terms multiply 2 terms, trinomial times binomial, 1, 2, 3, 4, 5, 6 terms. Now we will look to simplify by combining the like terms. X to the 4th remains the same. Positive 3x squared minus 6x squared. I start off with 3x squareds, but I take away 6x squareds. 3 minus 6, I have minus 3x squared. So this combines here. How many x squareds do we have? Well, 3 minus 6 is negative 3, so we have negative 3x squareds. Minus 12x cubed. There is no other term of degree 3. Minus 4x minus 2. So notice our remaining terms here all have degrees that are unlike. None of these are the same, so we are fully simplified. Now we just want to rewrite this in the proper form simply by switching around these two terms. With addition and subtraction, we can simply switch these. Negative 3x squared minus 12x cubed. Well, I'm going to take, because I'm subtracting either way, I'm just going to take these two terms and just move them around. I'm going to take this and make this this first term a minus 12x cubed. And what did my x squareds become when I added or I took this positive and I subtracted? Minus 3x squared. Okay, so my x squared is still minus 3. My x cubed is still minus 12. It's just now in the standard form, where my degree of the polynomial is 4, leading coefficient is 9, and the constant is negative 2. These next two examples show how to multiply polynomials in the vertical format. It says in the study tip there that when you're multiplying, make sure to have them written in the standard form. Fortunately for us, they are written in the standard form. Largest exponent term is written first, followed by the next largest. Looking at the first example, we have 4x to the 4th power minus 6x squared plus 9. We are multiplying to this 2x plus 3. Now, if we're going to use a multiplication sign for polynomials, normally we set them, like for example, number 74 in the previous examples, 56, 63, and 65, we set the parentheses next to one another to indicate multiplication. In the vertical format, they are using that little X symbol as you see there. I do not like that because notice that the variable that is also being used is an X. So cross multiplication, that's why we use the X sign. We learned that at a very young age, but we need to brush that off and stop using the X sign. Because it is the common variable for most all functions that we deal with independent variables. So I'm just going to use the little dot product there. The dot product also indicates multiplication. So we're multiplying a trinomial to a binomial. We should end up with 6 terms. Once again, 3 terms times 2 terms will give us 6 terms for which we will look to simplify using like terms. So in other words, when you have it stacked in the vertical format, let's just look, we want to look at the bottom polynomial here. We want to look at taking each term in the bottom polynomial and multiplying it to each term in the top polynomial. So starting off here, we'll start with the 3. 3 times 9, positive 3 times positive 9, right, that's positive 27. Positive 3 times negative 6x squared is negative 18x squared. Positive 3 times positive 4x to the 4th, 3 times 4 is 12, times x to the 4th is a positive 12x to the 4th. Notice this degree of 4 didn't change here when we multiplied it by a 3. Multiplying it by a coefficient or a constant number does not change the exponent, right? Because there is no factor of x here. This x to the fourth stays x to the fourth. The 4 gets multiplied by the 3 to get 12. X squared stays. Negative 6 times 3 is negative 18. This positive 9 times positive 3, positive 27. Now, let's look here at multiplying by a 2x. Again, when you multiply by a 2x, you're multiplying by a 2 and an x. So each of these numbers here, think about them being doubled. Multiplying by a 2, a 4 becomes an 8, negative 6 becomes negative 12, 9 becomes 18. But you're also multiplying in this factor of x. Multiplying in this factor of x is going to change the exponent or degree of each of these terms up here. Let's go ahead and try it out. 2x multiplied 9, 2 times 9 is 18, but it's also gaining a factor of x. So this isn't just 18, it's 18 times x, or simply positive 18x. So off anywhere here, positive 18x. I'm running out of space, so I can't really plug this in anywhere, but we'll know at the end we're going to write it in standard form. 2x times negative 6x squared. 2 times negative 6 is negative 12. But x times x squared is x cubed. Lastly, 2x times 4x to the fourth. 2 times 4 is 8, but x to the fourth times x is x to the fifth. Three terms multiply 2 terms, or 2 terms multiply 3 terms, we get 6 total terms. Notice when you multiply by just one single x, you're simply just adding 1 to this exponent here. X to the fourth multiplied by x to the fifth. The x squared becomes x cubed. The 9 didn't have a factor of x, but now we have the factor of x here, 2 times 9 to give us 18x. Can you combine any of these terms together? Do any of them have the same degree? Degree 5, degree 4, degree 3, degree 2, degree 1, degree 0. All degrees are different. All exponents of the variable x are different. We cannot combine any of these 6 terms together. So strangely, this product here of 6 terms, or this result of 6 terms, cannot be further simplified. So this is our resulting polynomial. We just now want to write it in standard form. Largest exponent first. Largest degree is the positive 8x to the fifth. Plus 12x to the fourth. Minus 12x cubed. Minus 18x squared. Plus 18x. Plus 27. So we have a 6-termed polynomial where the degree of this polynomial is 5, the leading coefficient is 8, and the constant is positive 27. We'll go to that next example, number 74. And again, we're being asked to multiply it in the vertical format. If you feel comfortable multiplying this in the horizontal format, I encourage you to stay there. Do what is going to be most efficient for you. Just to see this in the vertical format, let's go ahead and multiply trinomial times trinomial. 3 terms times 3 terms equals 9 terms. Let's go ahead and see what these 9 terms give us and what we can do to simplify them down. X squared plus 2x plus 5. Is going to multiply 2x squared minus x minus 1. And see down here when we multiply, notice we're working with some nice numbers here. Minus 1, a minus 1x, a positive 2x squared. So the numbers aren't too big there. We're just multiplying by 1s and 2s. Nothing too bad there. All 3 terms here need to multiply all 3 terms up here, giving us 9 terms. Let's start with the negative 1. Negative 1 multiply positive 5 is negative 5. I'm going to have to use all the board here because I'm going to run out of space with all these terms. Negative 1 multiplied 2x is negative 2x. So notice here, when you multiply by negative 1, again, you're just simply changing the signs for each of these terms here. This becomes negative 5, this becomes negative 2x, this becomes negative x squared. That's kind of the odd thing about multiplying by a negative 1. It's just simply going to change the signs of each of those terms. And we're done with that factor. Here, the minus x times positive 5 times negative x, negative 5x. Well, here's negative 2x. I'm going to stack the negative 5x right below, because as we see, those are like terms. We need to get used to that. Negative x times positive 2x. Negative times positive is negative. 2 times x is 2x squared, negative 2x squared. Negative x times x squared. Well, x squared times x is x cubed, times the negative is negative x cubed. Two x squared times positive 5. 5 times 2 is 10, times x squared is 10x squared. 2x squared times 2x. 2 times 2 is 4 times x squared times x. That's 4x cubed, right? X squared times x is x cubed. So we're going to get a 4x cubed. Last product here, 2x squared times x squared. 2x squared times x squared is 2x to the fourth power. Of course, that is positive. Notice here, for all of this product here, these three terms, multiply these three terms, give us 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, for which we will combine the like terms, minus 2x combined with minus 5x. How many x's do we have? Minus 2 and minus 5 combined to give us minus 7x. So this equals minus 7x here. How many x squareds do we have? Well, here we have negative 1 combined with a negative 2. Negative 1 combined with negative 2 is negative 3x squared, but a negative 3x squared combined with a positive 10x squared, right? That positive 10 is going to shoot it back up in the positives. Negative 3 plus 10 is positive 7. How do we know that? Because 10 minus 3 is positive 7. So when you combine these negatives here, there are negative 3x squareds. Negative 3x squareds combined with positive 10x squared is positive 7x squared. How many x cubes do we have? Minus 1 plus 4. Minus 1 plus 4, or 4 minus 1, that's plus 3x cubed. So what is our simplified polynomial? 2x to the fourth power plus 3x cubed plus 7x squared minus 7x minus 5. Well, let's go ahead and write that properly. We don't want to just leave it like that, right? But we're seeing that if we're working on the side, if we're working on scratch paper, if we're formulating these ideas in a way that we understand it and that we can express it to a viewer or a reader or an instructor, then it's okay. This is all very logical understanding of how someone might think about breaking down this problem. But now putting it together, let's write out a proper standard form polynomial. Our first term, largest exponent, 2x to the fourth power. Our second term, plus 3x cubed. The third term here, positive 7x squared, or plus 7x squared. The fourth term, minus 7x. And the last term, because it's our constant, minus 5. So the product of our two trinomials leaves us with 9 terms, and we simplified it down, our 9 terms, into a 5-termed simplified polynomial, where the degree of our polynomial, after multiplying, we get a resulting polynomial, where the degree of our polynomial is 4, the leading coefficient is 2, and the constant is -5.